So like arithmetic series, geometric series are the sum of a geometric sequence. Okay, so when we added the arithmetic series up, or sorry, sequence up, we ended up with a series. Same thing if we add this geometric sequence. So this is geometric sequence, first term, second term, third term, the nth term. When we add up this sequence, we're going to get a geometric series. Okay, and the sum of the n number of terms of a series looks like this. Okay, so same thing with geometric sequences, the Tn formula. We need to know how it progresses. We need to know the A, we need to know the R. Okay, so those are two main things we need to know. N just lets us figure out where we are in the sequence, and the Sn is the total. So this is not quite as straightforward because there's more parts to this because we're adding this all together. So that it's not just like finding out one part of this progression. We need to find out the sum of this progression. So how do we get this formula? Well, if we take a look at the sequence here, if we add up every term of the sequence, we get Sn, and it looks like this. Okay, so here are the terms of sequence. So what we're going to do with this sequence is we're going to times everything by r. And what that ends up doing is the a becomes ar, ar becomes ar squared becomes ar cubed, etc. And arn minus 1 becomes arn. So this is our original series. This is the series when we multiply it by r. So what we're going to do, and the reason why we do this is notice that now we have everything inside matching. Even it doesn't matter how far we go for n minus 1. There's always an n minus 1 that will account for that. And since that's the case, we're going to subtract. So we're going to take the bottom row, and we're going to subtract the top row. Okay, so it's going backwards, the subtraction. So we're going to take this. These are going to cancel. These are all going to cancel. We're going to have that and subtract that. So that's all we're going to be left with when we subtract the bottom and the top. So x times r times s minus sn just leaves us with two terms, arn and a minus a. So it's going to be that one and that one. So everything else, and I'll just diagram that here. These cancel, everything in between cancels, and we're just left with that term and that term. So I can solve for the Sn. That's really what I want. I want Sn. I want the sum. So I'm going to factor that out here, and then I'm going to solve for this Sn by dividing both sides by r minus 1. And here the numerator factor is a, and we end up with the formula that we have up here. Okay, so this is our formula. And again, the two things that we need to know are our sum starting point and the r for our progression. So when I look at these problems, what I want to do is I want to see if I can find those pieces. Okay, so I have my a is equal to 2. My r I can find by dividing consecutive terms. So 6 divided by 2 is equal to 3. If I want to find the S10 then, well, I could list out 10 terms. So if I'm ever stuck, I'm going to list out 10 terms. I'll just finish. I've got 4 and times by 3. I think that's 162 plus 1 times by 3 again, 146. 1, 2, 3, 4, 5, 6. And I'm going to list out 10 terms, and I can just do grunt work and just work it out that way. 10 terms start to get to be a lot of terms, so I know that this formula is going to be way more efficient. So I'm going to plug in my formula. A r to the power n, so n is 10, and it's going to be all over r minus 1, so r is 3 minus 1. This simplifies to 3 to the power 10 minus 1 times 2 divided by 2, those cancel out. So when I add up the total sum of all these 10 terms, I'm going to get 3 to the power 10 minus 1, and I'm getting 59,048. Okay, so that is the sum of the first 10 terms, and that seems reasonable because I'm getting very big very quickly with geometric sequences. Okay, so that's generally the geometric sequence. Now just try to understand how the algebra works for geometric sequences. I know that the Tn is going to be found from Sn minus 1. And that's the reason is because if I take the sum of n minus 1 terms and I add the next term, okay, I'm going to end up with the sum of all those terms. So this represents all the sum of all the Tn's up to before Tn, and I add Tn, I'm going to end up with Sn. So the rearrangement of this formula ends up with that. So if I want to find out Tn, I can subtract terms. So this is an example here where I have S3 and S4, S4 and S5. Well, and we're told this is a geometric sequence. Actually, it doesn't say that, but we have to assume that. So I know that if I subtract, we can go S4 minus S3. If I take the first 4 terms and I take away the first 3 terms, I'm left with a 4th term only. Okay, and again, this works not just for our geometric, it also works for arithmetic series because that's the nature of a series. We're adding up terms. Not just with the arithmetic series, but in fact with any series. But this allows us to get T4. So in this case, T4, when I work this out, is equal to 81. Okay, well that's useful. And here, notice that I got consecutive terms, so I can do S5 minus S4, and that's going to give me actually the 5th term. Well, 363, what's my funny 363 minus 120 is going to give me 243, which is my T5. Well, now notice that I have consecutive T terms. Okay, if I have consecutive T terms in a geometric series, I know that T5 over T4 is going to give me R. So 243 over 81 gives me an R value of 3. So I can find, if I know R, I can probably work backwards here to figure out A. Okay, so I know that T4, what was T4? Is 81. So I know I have 1, 2, 3, 4. That's 81. I can work backwards, divide by 3, divide by 3, divide by 3. I know the first 3 terms are going to be 3, 9, 27. If I want to solve for S8, I probably, I can write out 8 terms, but again, I'm probably better off using my formula now since I have R and I have A. Okay, so these are the key parts. I'm going to write this down over here just to make sure I have it all compiled. A and R. Okay, A is 3, R is 3. So S8, my formulas depend on A and R. So I'm going to end up with A, R to the power 8 minus 1 over R minus 1. So I end up with, what's that going to be? 3 to the power 8 minus 1 times 3 divide by 2. Okay, so I get 9840 as my sum. Okay, so that's going to be S8. And I think I've answered the question. I've got my first 3 terms. I've got my S8. And again, the key is to make sure you see if you can get A and R. That generalizes things. And the property I used to get this was to use this difference of consecutive sums gives us the values for t. And once I found some values for t, I could divide to get ratios. Now notice I want you guys to be very careful because if I divide s's, okay, this does not equal the ratios because there's pluses involved with our s's, right? So once I start involving pluses, that doesn't allow me to figure out times and divide math. It's actually very complicated. It becomes much more complicated when we do that.